Hello, physics students. This is Dr. Brenzi here. This is lesson 2.2.1, and we are learning about tension and pulleys. We already have done some problems with tension, but now we're going to be pulleys, or bring pulleys into the mix here. And what a pulley does is it changes the direction of a string's tension force. So if I have a block here and it's experiencing a tension force going toward the right, then this pulley actually changes the direction of that tension force so that it is pulling up on this other block right here. Now, one thing that you can assume about tension along this entire rope is that if the pulley's mass is negligible, in other words, if it's small enough that we can consider it zero, then the tension is constant throughout this rope. Okay? In other words, if this block here experiences a tension T1 toward the right, then the other block experiences a tension of the same magnitude but in a different direction, namely upward. So, let's say, well, when you're dealing with tension problems and you're trying to solve for tension and sometimes acceleration, we need to first draw a free body diagram. That's the first thing that we do. So we're going to draw a free body diagram for each of these bodies, block A and block B. So let's draw a free body diagram for block A. Well, it's experiencing a normal force and a gravitational force. It experiences a friction force because it does say that the table is not frictionless. And it experiences a tension toward the right. Okay, now for block B experiences a force due to gravity and experiences a force due to the tension of the rope. So block B has a simpler free body diagram than block A does. Now, when I go to solve problems involving acceleration of this block and this block over here, the normal force and the gravitational force are perpendicular to the acceleration that I would expect this block to experience. So, I'm not going to worry about this normal force and this gravitational force. So when I set up F net equals ma, since I don't expect any acceleration in the vertical direction for this block A, I'm not going to worry about setting up a y direction for this block A. So let's find the acceleration of each of these blocks. Now for block A, like I said, I'm only going to consider the horizontal direction because the vertical direction is going to be kind of boring and it's not going to really play into how this accelerates in the horizontal direction. I say boring because we would just set F normal equal to F gravity and that would be it, right? So, for this particular problem, I'm going to write F net equals ma, Newton's second law, and the horizontal direction has a tension toward the right and a friction force toward the left, and that is equal to mass times acceleration, which is 8 times a. And before I get too much farther, I need to tell you that the friction force on this block is equal to 10 newtons. So, oops, that should be newtons right here. I don't know why that ended up being 101. I think I just forgot to finish writing my symbol newtons. This is 10 newtons, not 101. Alright, so this friction force is 10 newtons, which is why this is minus 10, because that is in the negative x direction. Okay, now let's go on to the y direction. Or, I'm sorry, not the y direction, for block B. So F net for block B in the y direction equals ma, and its tension is in the positive y direction. Minus mg is equal to m Now this is where we have to do a little thinking here. You'd probably think I would just put MA here, but let's think carefully. If this block A, is accelerating to the right by a value A, which direction will this block B be accelerating? Well, it's going to be accelerating down. So instead of putting MA in here when I'm filling in each of my values, I'm going to put M times negative A. Because if A is accelerating in the positive X direction, then B has to be accelerating in the negative Y direction. So make a note of that before you go on, and if you have to pause the video, go ahead and do that. So let's go ahead and solve this equation for the tension force. And then I'm going to plug that expression into this equation to find acceleration. So let's do that. Oops. I think I'm going a little too fast for you here. Let me back that up. All right. So what I did right here is I just rewrote mg with the actual values in there, 10 times negative 9.8. And then over here, I'm solving for f of t now, and I add 10 to both sides. That gives me f of t equals 8a plus 10. So that's the expression that I'm going to plug in for f of t over here. So let's do that. So I have 8a plus 10 minus 98, because that's negative 10 times 9.8, equals negative 10a. Okay. So let's go ahead and simplify this right here. We have, actually, I'm going to, I guess I didn't. Okay, so before I do that, actually what I'm going to do is I'm going to subtract 8a from both sides so that I get all of my a terms onto one side of the equation. And when I do that, I subtract 8a from both sides and I get negative 88, because that is equal to 10 minus 98, so that's how I got negative 88 here. And then negative 10a minus 8a equals negative 18a. So I divide both sides by negative 18, and I get a equals 4.9 meters per second squared. Okay. Okay, now let's apply that to finding the tension on each side of the rope. A second look back here, and I realized that, I mentioned negative 4.9 meters per second squared, but the answer I got was actually 4.9 meters per second squared, so let's change that to positive there. And if you're wondering how I did that so fast, I actually had to pause my video to take a second look at that. So let's write the tension force, minus 98 equals 8 times 4.9. Now, if you're wondering how I got this equation, well, that was the equation of F equals ma for this 8 kilogram block, which we called block A. And I'm just plugging in the acceleration, which is 4.9 meters per second squared. And we go ahead and we solve for f of t. And when we do that, we get something on the order of 140 newtons. Okay. So here's another example that we might run into very commonly, is that we have two blocks and both of them are suspended by a pulley. One of these will experience an acceleration downward. So if this block is accelerated downward, this other block is accelerated in which direction? Well, it's going to be accelerated upward with the same magnitude. So we would consider this negative A, and we would consider this positive A. Now you might be wondering, Dr. Brenzy, wait a minute, isn't this the negative X or Y direction? Yes, it is. That is the negative Y direction. And what I would expect if I set up my problem this way, and this really was accelerating downward, is that this block, or this acceleration, will be a negative number, which will tell me that I got my numbers mixed up. In other words, or my directions mixed up. So I'm sorry, let me say that again. Let me back up. So what I would expect is if I made this